Alright, so in this video I wanted to talk about how you can talk to your DB like you have a database, then using natural language, how you can like fire certain questions to that database and retrieve that answer, right? So this database is generally a relational database where the data is present in terms of different types of tables, and tables are having primary key foreign key relationship, and with that the relationship is established in the database. And what we will do is, with the help of LangChain and LLM, we will fire questions in terms of natural language, and we will expect that with the help of LangChain and the LLM that we will use, it will kind of translate that natural language to a SQL query, which again it will be fired to the database to retrieve the desired result, right? Okay, so the database which we will use is kind of one of the famous data set that is also present in this MySQL tutorial. So you can just download this MySQL sample database, and then what I have done is I have downloaded this data set or the .sql file, and I upload it as a dataset in Kaggle kernel, and then I am using it in the Kaggle kernel, right? So you can see like there are different types of tables which are present, like customer, products, order details, payments, offices, employees, and the product lines, right? So this is typically a data set which is related to a retail customer, right? So with this data set we will try to see how to fire natural language to this particular database, and how we can like get the answers in a more structured format and more okay. So let's jump into the code. So first of all, like I will install the MySQL connector Python, which is required to to install the DB and also to work with to create certain connections with the database. So what we will do is, at first we will create the database inside this notebook, and using the .sql file we will kind of load the data set along with the table structure, and then we will create certain operations with the help of LangChain and LLM, through which we can fire the natural language, which will again translate to the SQL, right? So after that, like MySQL installation I am doing. So all this I am doing to create the database just inside this single notebook, right? So with that, like you can create a database and then you can play around in a single notebook, right? So then I'm starting the MySQL service, then some stuffs which are related to user ID and password creation for the account. Then I'm creating a schema. I'm naming that schema as classic models, which is also given as the schema in this documentation or the tutorial of this MySQL sample database. And then what I'm doing is I am running this .sql file to create the database along with the data and the table structure, right? So then what I'm doing is I'm just creating a connector which is using the user ID, password, and mentioning the host, and then using that cursor I'm just trying executing certain commands, which is like SQL commands. So at first what I am doing is I'm executing use classic models. So it's kind of selecting the schema, the database that we have just created, and with that it will try to fire certain queries and retrieve the answer. A regular function which I created, so using this cursor we will execute these queries, and using this cursor.fetch all we can get back the results by firing certain queries. So what I have done here is I have created a function which will kind of give you back the results, right? So first of all I am just running a SQL command show tables, and then calling this print record function, which tells you like what are the tables that are present inside the database. Then I am again firing a simple SQL statement which is like select star from customers. There are installations which are required, like we are using Palm2 as an LLM, so we are installing the Google Generative AI, and also we are installing the LangChain along with the LangChain experimental, right? So once the installations are done, at first we are initializing the LLM, which is nothing but Google Palm Palm 2 model, and specifically for this example I am using the code bison because here we are generally trying to generate a SQL code through which we will try to retrieve our desired output, right? So that's why I have specifically chosen the model which is like code bison, which is like a LLM which is optimized for code generation, right? So we have different types of model in llama 2 also. So they are like code llama is one of the model which is specialized for code generation. So as we don't need any creativity and we need like specific code generation, that's why I'm mentioning temperature equals to 0.0, and also I'm mentioning like top k equals to 1 and repetition penalty equals to 1.2, right? And with that what I will do is I will import these two functionalities which are like SQL database and another SQL database chain, right? So using the SQL database we will establish the connection between the database to the LLM, and we are using certain parameters like the username, the password, the host, and the database name, right? So we pass all these parameters, kind of a URI thing, and with that we are creating the database, right? So once we kind of create the database, we are kind of running this db.tableInfo, which will give you a details of all the tables that are present inside this schema, right? And here you can see like I have mentioned sample row in tab equals to 3, right? So with that it will also give you like while creating the connection it will retrieve the first 3 rows from the tables, which is kind of an extra metadata which we are incorporating in the while creating the connection, right? So which can be beneficial when we are like firing certain complex queries. So if in case like we are firing complex queries, your LLM can already be aware what are the like top 3 rows that are present in the each of the tables. So with that it will have an additional knowledge to build certain optimized queries. So once that is done, what we can do is, so these are all the table details, then we will do is we will create a SQL database chain. So we have seen like we created a question answer kind of chain, a simple sequential chain or sequential chain. Then in last video we have also talked about graph QA chain, right? So here what we are using is SQL database chain, and using the SQL database chain, then what we are doing is from LLM we are passing the LLM, the database, and also we are mentioning verbose equals to true, just that we want to see the flow of the code generation and how the optimal result is kind of fetched from the database. Then we are also mentioning that use query checker equals to true. So once we mention this use query checker equals to true, so it will try to validate the query before firing it to the database. So it's kind of a extra precautionary measure which you can do to make sure that the queries are properly generated and well formatted, right? So then I am kind of running certain questions which are like I am passing natural language, and I am trying to talk with the database with natural language, which will in turn generate the SQL query in the backend, and it will try to fetch the results using that SQL query, right? So what I'm doing is db chain.run, then I'm passing the natural language query, what are the order related tables we have in this schema, right? So then it's firing the SQL query, and using that SQL query it will try to retrieve the values, right? So from the information schema dot tables, right? So we have based on the natural language it's adding the where clause, and with that it's retrieving the answer which is order details and order. So these are two order related tables that are present in my schema. Then I am asking like tell me who are top 5 high performing products in terms of revenue, right? So we are trying to bring out the information who are the, like what are the top 5 high performing products that are available in this database, and that we are trying to fetch based on in terms of revenue, right? So you can see it's creating a complex query like as with aggregate functions along with certain group by operations, and then it's doing order by, and it's limiting the results by 5 to select the top 5 products based on the revenue, right? So here we are kind of seeing the product code, right? So now what I am asking is, instead of fetching the top 5 product codes, you fetch the top 5 high performing product names, right? So I'm categorically asking what are the top 5 product names that are available in this data set, right? So then it's, instead of picking up the codes, it's selecting the product name, and then it's doing the aggregate operations along with group by, and it tells you what are the top 5 product names that are present in this data set, right? So then again I'm asking, like, tell me who are my top 5 customers name with highest number of orders. So I just wanted to see who are my top 5 customers who are frequently like creating certain orders or placing orders. So that also, those names we can see here. So yeah, so this is all I wanted to talk about for this natural language to SQL code generation using LLM in this video. So you can go ahead and like create a copy of this notebook and try to play around with some complex queries, and let me know in the comment like how the results are coming out if you are like firing very much complex queries or the natural language queries to the database, right? So with this I will end this video. I hope you got an understanding of how you can use LLM to convert a natural language to a SQL query generation. So this type of applications are nowadays getting very popular, like we are creating a certain chatbot type of thing where we are kind of enabling the end users to talk with the database in terms of natural language. So they don't need to understand like what goes on behind the scene. They will just fire natural language and try to retrieve the desired output, right? So yeah, I hope you like this video. If you haven't subscribed this channel, please subscribe and share this video with your friends and colleagues. Thank you. See you in the next video.